ర్యాంకిన్ సైకిల్ని వేపర్ పవర్ సైకిల్ అంటారు. అయితే హీట్ ఇంజన్ దట్ కన్వర్ట్స్ హీట్ ఇంటూ మెకానికల్ వర్క్. అంటే హీట్ ఇంజన్ ర్యాంకిన్ సైకిల్ ఏంటంటే హీట్ ఇంజన్ కన్వర్ట్స్ ఇంటూ హీట్ ఇంటూ మెకానికల్ వర్క్. హీట్ నుంచి మెకానికల్ వర్క్ కన్వర్ట్ అయ్యేదంటే ర్యాంకిన్ సైకిల్ అంటారు. ర్యాంకిన్ సైకిల్ ఈజ్ ఎ రివర్సిబుల్ సైకిల్. బాయిలర్. ఈ బాయిలర్ అనేది రివర్సిబుల్ కాన్స్టెంట్ ప్రెజర్. టర్బైన్ అనేది రివర్సిబుల్ అడియాబాటిక్ ఎక్స్పాన్షన్. కండెన్సర్ వచ్చేసి రివర్సిబుల్ కాన్స్టెంట్ ప్రెజర్. అదేవిధంగా పంప్ వచ్చేసి రివర్సిబుల్ అడియాబాటిక్లీ ఎండింగ్ ఎట్ ఇనిషియల్ ప్రెజర్ వస్తుంది. స్టడీ ఫ్లో ఎనర్జీ ఈక్వేషన్లో కంట్రోల్ వాల్యూమ్లో వచ్చేసి Q1 = H1 - H4 వస్తుంది. స్టడీ ఫ్లో ఎనర్జీ ఈక్వేషన్ టర్బైన్లో వచ్చేసి బాయిలర్లో వచ్చేసి Q1 = H1 - H2, టర్బైన్ వచ్చేసేమో H1 - H2, కండెన్సర్లో వచ్చేమో H2 - H3 వస్తుంది. ఈ విధంగా డయాగ్రామ్ ఉంటుంది. సో స్ట్రీమ్ రేట్ వచ్చేసి 1/W నెట్ వర్క్ నెట్ వస్తుంది. అదేవిధంగా ఇక్కడ ఏంటంటే హీట్ రేట్ వచ్చేసి Q1/W2 - WP 1 ఎఫిషియన్సీ kJ/kW. ఇక్కడ ఎకనామైజర్ వచ్చేసి H5 - H4 వస్తుంది. ఎవాపరేటర్ వచ్చేసి H6 - H5. సూపర్ హీట్ వచ్చేసి H1 - H6 వస్తుంది. హీట్ సప్లైడ్ మైనస్ హీట్ రిజెక్టెడ్ బై హీట్ సప్లైడ్. ఈ విధంగా రీహీటింగ్ ఆఫ్ స్టీమ్. సైకిల్ ఎఫిషియన్సీ ఇంప్రూవ్ విత్ రీహీట్. ప్రెజర్ రేషియో PM/P1 between 0.20 and 0.25. Efficient WT - WP/Q1. Reheating steam also increases the network output of the turbine. స్టీమ్ జనరేటర్ ఈ విధంగా ఉంటుంది. అదేవిధంగా రీజనరేట్ సైకిల్ డస్ నాట్ ఎఫెక్ట్ వర్క్ అవుట్పుట్ ఫ్రమ్ టర్బైన్. ఇస్ మోర్ డిఫికల్ట్. హైయర్ స్ట్రీమ్ రేట్ వస్తుంది. అదేవిధంగా ఎఫిషియన్సీ ఆఫ్ సైకిల్ వచ్చేసి నెట్వర్క్ అవుట్పుట్ బై హీట్ సప్లైడ్ వస్తుంది. డస్ నాట్ కంబైన్డ్ సైకిల్ పవర్ జనరేషన్ ఇంక్రీజ్ ద ఓవరాల్ ఎఫిషియన్సీ ఆఫ్ హీట్ ఇంజిన్. అదేవిధంగా చార్జెస్ ఆఫ్ ద ఐడియల్ వర్కింగ్ ఫ్లూయిడ్ వచ్చేసి స్పెసిఫిక్ హీట్ ఆఫ్ లిక్విడ్ షుడ్ బి స్మాల్. The fluid should be chemically stable, non-toxic, non-corrosive, non-excessively viscous and low is cost. Efficiency of cycle. Binary vapor cycle efficiency cycle WT - WP/Q1. M of HV - HC = H6 - H5. Britain's Rankine combined cycle with plant. Britain cycle W1 = WT - WC. Rankine cycle W2 of WT - WP. When plant in series, W1/Q1 into W2/Q3. Friction of heat supplied which is loss QL/Q1. When plants operates in a parallel, XL = Q4/Q2 plus Q4. అదేవిధంగా డ్యూలింగ్ అండ్ పిటెడ్ ఫార్ములా HHV 333.83C plus 144.45 H - 0/8 plus 9.38 S. అదేవిధంగా ఓవర్షెట్ గ్యాస్ అనాలిసిస్ ఇస్ ద 100% వాల్యూ. హై ఆఫ్ చిమ్నీ H is equal to 353H 1/TA minus M plus 1/M 1/TG mm of water. Condition for maximum discharge through the chimney. The drought in mm of water column 353H by 2TA equal to 176.5 H by TA. Turbine, steam turbine into shaft work with a low temperature steam exhaust in a condenser. Gas turbine, nozzle, combustor and nozzle in addition to one or more turbines. For symmetrical blades, beta 1 is equal to beta 2 pi dmn/60. ఎందుకే tangential thrust PD = WS minus delta VW. axial thrust PA = WS delta A. area of the flow pi dm1 H5. అదేవిధంగా ఎనర్జీ లాస్ డ్యూ టు ఫ్రిక్షన్ ఇన్ బ్లేడ్స్ ఈక్వల్ టు ద V1² minus VR1²/2. ఆప్టిమమ్ వెలాసిటీ ఆఫ్ VB/V1. Nozzle angle has to maintain within a certain reach which varies from 16 degrees to 22 degrees in impulse turbine. One row is nozzle forward, one row blades is called as stage compounding of a turbine. Delta H pressure compounding వచ్చేసి delta H total by N. The velocity of steam from the first flow, the 1 by 2, 44.7 H1 minus H1 1 by 4. For 4 stages of velocity leaving nozzle, each stage 1 by 2 of single stage. For 9 stages of velocity leaving nozzle, each stage 1 by 2 of single stage. And blade velocity is given by cos alpha by 2 into V1. Delta H stage 4 of VB by 44.72 cos alpha whole power of square. Collapsed compound కుట్టి స్టేజెస్ వచ్చేసి ఈ విధంగా, బ్లేడ్ ఫ్రిక్షన్ వచ్చేసి ఈ విధంగా ఉంటుంది. The tangential thrust PT is equal to WS of delta W1 plus delta W2. The axial thrust WS delta A1 plus delta A2, and bending diagram work W PT into VB. Blading diagram work, the blading diagram efficiency and 2WdV VB by V1 square. The ratio of work done steam engine blades in the 2 rows of cutties is the 3:1. It means 3 by 4 is the work done the steam engine first moving blades, 1 by 4 of the total work done the second type moving blades. 3 rows of cutty stage 3:2:1. As the number of rows moving blades in the cutty stage increases, effectively the later rows decreases. And optimum velocity ratio for cutty stage PW cos alpha by 2Z, and 2 rows cutty stages ND cos alpha whole square by VB equal cos alpha by 4 into V. VB by 16 of VB by 44.72 cos alpha whole square. Reaction turbine, this is the degree of reaction delta H by delta HM by delta H. R is equal to 100% pure reaction turbine, Hero's turbines. Beta 180 minus delta. Delta equals 0 in 50 degrees reaction turbine. There is no axial thrust. Pressure difference. Across the blade, each root or disc, there is the pressure drop in the steam across the moving blades. And comparison of entropy drops in various stages. In 2 rows of cutty stage 1:2:8. In this case, the energy input of a blade per kg V1 square by 2 plus VF square minus VF2 square by 2, and beta equal 180 minus alpha. Velocity diagram of 50% reaction turbine is there. 2 cos square alpha by h cos square alpha. Specific blading work corresponding maximum blade efficiency delta VW VB equal VB square. A gas turbine also called as a combustion turbine. This is the combustion chamber is there. Pressure ratio P2 by P1. The ideal cycle, the working fluid undergoes in the closed loop is the Brayton cycle. The efficiency of reheating is the cycle efficiency is the decreases. When the reheat is the cycle efficiency is the decreases. It can be shown in that optimal reheat pressure of a maximum work in P1 P2 whole power of 1 by 2. This is the compressor. Compressor is losses in a compressor. CDS 0.018 CL whole square into CDA 0.020 HH. The slip 8 tapered between the impeller blades, and under ideal conditions CW2 is equal to U2. Slip U2 minus CW2. Slip factor 1 minus 0.63 pi by N. And the efficiency of Cx by U is called as flow coefficient. Work done factor and its values varies between 0.98 to 0.85 depending on the number of stages. Radial equilibrium flow, the radial equilibrium flow. This is known as a free vortex condition. This condition gives the air angle and a reaction as shown in the figure. For forced vortex condition is Cy by Cry. And combustion chamber, 1 or 2 large cylindrical type of combustion chambers is there. Can type of combustion with swirl flow flame stabilizer. Can type of combustion with bulb body flame stabilizer. A blade angles gas turbine follow the axial flow compressor, where the degree of reaction is not 50%. Degree of reaction R is equal to VF into T bit 10 bit by 2 VB. Biometric condensers, falling cooling on a series of baffles large surface area, and non-condensable steam is the air injector. Jet condenser similar as the barometric but use diffuser. Thermal pollution but requires 4 times of pumping power and twice the water flow. The tube material cupronickel 70% Cu, 30% Ni. Aluminium brass 76% Cu, 22% Zn, 2% of Al. Munt metals is the 60% Cu, 40% Zn. And Admiralty alloy is 71% Cu, 28% Zn, 1% Sn. And open feed water is the hammer. It is a 3 types of spray type. The tray type is combined spray type adequately. And nozzle is the velocity of fluid increases at the expense of pressure drop. Diffuser is fluid decreases and corresponding increases pressure. Stagnation properties stagnation enthalpy H plus V1 square by 2. Velocity of sound should be defined as C is equal to root of gamma RT or delta P by delta S. Match number is equal to defined as the ratio of actual velocity of the sonic velocity m is equal to V by C. Subsonic and supersonic nozzle is the isentropic flow through nozzle dou A by dV dV by dV square 1 minus m square dA by A m square minus 1 dV by V. When m less than 1 is the initial velocity, subsonic as flow area decreases when pressure decreases and velocity increases. Convergent null. M greater than 1 increased velocity of supersonic as the flow increases process decrease in the velocity of increased divergence. M less than 1 is the subsonic, m greater than 1 is supersonic. M less than 1 is subsonic, m is decreases, A is the increases, and m greater than 1 is supersonic, m decreases, A is decreases. The area D is 0 for sonic condition m equal to 1 including a minimum cross section and a so-called road. M greater than or equal to 0.2 range of incompressible. Mass flow rate is the maximum mass flow per unit area 1 stagnation pressure 1 by root of stagnation temperature. And nozzle velocity coefficients of root n. Nozzle discharge coefficient of CD m actual by m isentropic. Constant area adiabatic flow is the dH equal minus VdV. Key points for enthalpy and entropy of match number of entropy diagram. Constant area functional flow, heat flow, rainless flow. Continuity equation dP by P equal minus dV by V. Continuity equation. First of thermodynamics dQ is equal to dH. dV by minus 1 by km square dP by d. Momentum equation is the impulse function. P plus rho V square is equal to equation of state. dP by equal to P by d plus dP by d. Rayleigh lines dP enthalpy of entropy. Rayleigh line is the enthalpy and entropy with constant area function. dt by t equal to dP by P 1 minus 1 by km square. And increases for m less than 1 by root of k, decreases for m greater than 1 by root k, decreases. M less than 1 by root of subsonic, m greater than 1 by root k, the supersonic is there. Increases for m less than 2 by root of k plus 1, decreases for m greater than 2 by root of 2 by k plus 1. Shock, sudden changes occurs in the discontinuous thermal shock. Strength of shock is the P is equal to 2k by k plus 1 m square plus 1 m square minus 1. The normal shock is the subsonic is m less than 1. P1 plus rho 1 V1 square is the P2. For always subsonic after a normal shock, m2 decreases, m increases normal shock, m2 square is k minus 1 by 2k. Okay, thank you.